Hi, everyone. Good afternoon, good morning, good evening, wherever you are. Hello and welcome to Learn with Dummy. Yes, I call myself Dummy because I'm always learning and upskilling. I'm passionate about data, and here today I'm going to talk with you or share with you my knowledge on Spark, Partition, from logical approach. Now I'm sure, and I guarantee you, first of all, that this is not a technical sharing. This is very practical and extremely logical. I'm sure you have, like me, you have seen so many technical videos from amazing people on YouTube. You might be working in the field or wondering, like me, I have worked in Spark, PySpark, but just sometimes we really need to know bit of under the hood. So how I'm calling it, it's more of a this is more of a driving a car, not actually being like being a mechanical engineer, if you know what I mean. So let's start. So the way I work, I'm very passionate about data and I work logically and technically. So I just thought to share my learning with you or understanding about Spark partition. So let's get started. Now, this is extremely logical and practical work notes. So what I have decided to do after learning, reading, understanding, watching YouTube videos on the subject, I decided to start from scratch. So what we're doing here today, we just hypothetically call ourselves that we are working for New York taxi company, and the business wanted us to download this file using PySpark, and just simple, nothing complicated. Just bring it into our storage and just save it. Now, when we say that we're going to work with Spark or PySpark, we know Spark is very intelligent, very fast, um, and you know all the theory behind it. So I'm not going to bore you with that. But let's see how we actually practically in kind of a real world use it. So to start with, just a bit of the platform, or the system. I'm working on a Windows 11. I recently downloaded the PySpark using Anaconda, and I'm running a Jupyter notebook on Windows 11 PC. Now the version I'm working on is 3.5.1. Recently, I learned that there could be many versions, and was not, as long as you have a Spark working, should be fine. Now I learned that in Jupyter we need to run this simple code just for find Spark. Now, where do I start? So as we know theoretically that Spark is a course and executors and task, and but how do we decide on a partition? And if you were like me wondering that is it just a guessing game or trial and error? Yes, it is. Um, it is like there is no silver bullet to tell us that, oh, this is the data and this. There are some logic. So when you work with the partition after understanding the theory, we need to learn really, really logically. And that's what I'm going to explain here. So let's find out. So what I did, I first ran this simple code, and I know, okay, I have 8 available cores. Now, my PC, I found out from a processes that my PC has a 4 cores, but it has a logical cores as well. So it says that 8 cores. Now, a bit of a theory that if our machine has a 4 CPU, it can physically execute 4 tasks. If we have a 8, it's 8 tasks, and 8 tasks equal to 8 partitions. That's how it works. Now, as I mentioned, we working for a New York company, so we download the file, simple Python code, nothing too complicated. Once your file is in the folder, obviously we check the schema. Now, as a rule of thumb or as a data person, I would always highly recommend, or I will always do, I explore the data just to make familiar. We're not expecting us to know everything about the data, but because when we're working for New York taxi company, we need to have a bit understanding of what the business is about, what their objectives are, why they're running the company, how they're running the company, how they're paying us actually. So just we need to know the commerciality of the company so we can understand the commerciality of the data and we can work strategically. Now, when as we all learn the theory and read about it about the Spark partition. Now Spark is very intelligent, so it has a default partitioning. Now, because this is the local Spark installation, we can't, like, at least I couldn't say how many partitions, so I just ran the code and let Spark to decide based on my 8 cores, and it gave me 8 partitions. So you see the number of records and 8 partitions. Hold on a minute. Yeah, I know. Now, then I did the count on the partition. I wanted to see how many partition got what. So when you run, this is the one way of running. It's only got gave me 3. Now you see it's close enough. 100, like a one some over 1 million, and then 806. This is good, but logically it has 8 and it's just giving me 3. So what happened to 5? Here you go. So when you run this code, it tells you all 8, and see how smart it is. It has so 5 are zeros. So Spark was working so fast and so smart. It let 5 with no like 5 executors or partitions are just 0. This is not really better way to work. Like it seems like you driving Ferrari like a Ute, which is not good. Anyway, so moving on. So I will. So it's a general rule of thumb in theory and all. What I found that we need every partition. We need to divide, like every partition should have 188, 128 MB. Now I just thought, oh, well, how do I know looking at the file? Like, okay, say, for example, I have a 2 million records here, but how much MB? And, do I want to really go and learn and, like, anyway, so I written this little code. What it does is just reads the file as a 0. It goes through the file, and then it's it's identified the total file size, and then it's divided into MB, and then it's telling us that. So what it will tell us that if total file size is smaller than 128, we don't need any partition, and if it's bigger, then it will say 2, 3, 4, 5. Now, see, interestingly, here it says that no partition is suggested. So if we go by 128 MB, our file is not even big enough to even run 3 or 8. Apparently, that's not either good because we can't have one partition and 7 blank. Like it's not even like driving Ferrari as a Ute. It's just like bullock cart, you would say, in a dummy word. Anyways, so what do I do now? Like, I just said, okay, so what are my options? So I said, okay, so now there is this logical cardinality. Now, cardinality is that you can think of partitions are like, as I said, it's trial and error. but it has like a Goldilocks thing, like not too hot, not too cold, just right. So you can't have too many partitions and you can't have too little partitions. So it's just right. Yep. Anyway, so what I have done, I said, okay, let's see the cardinality. So cardinality, just the logically, that cardinality is just like the column has to have some kind of a unique values. Like say, for example, um, vendor ID. So vendor ID in this instance has 1, 2, and 3 only. So that's good. You can say cardinality like a country is the very basic way to learn. Australia, India, UK, USA. So it's just like not random or unlimited, right? This data is turned out to be random, by the way, but we just not going there at the moment. We just, as I said, we're not doing anything complicated. Just simply we trying to get this file, download this file using PySpark and making it available. That it's just working fine now. Um, what so when we talk about the cardinality, see, payment type is file, so that's reasonably good enough. This is not cardinality. It's like over 1 million records. That's you can't we can't have that many um, partitions. Now that I think the maximum or default is 200. So in this case, we can't even have 260. But when it says just one, not even one required, we can't obviously have 260. However, we have 8, so I just thought, oh well, let's try with the vendor ID, because vendor ID is 3. I could have tried 3, but I just wanted to see what it does at 4. Now, obviously, the fourth one is 0 because there is only 3. But see, this is 260 to like 2 million and then 700. So this is again like, remember the Goldilocks, not too hot, not too cold, just right. This is not right. That's okay. Moving on, I just thought, oh, let me try something else. So I tried PU location ID. Again, you see, because PU location ID has more. As I said, that it has like over 260, but just to trial and error, I just thought, oh well, because location ID. Um, as I said, that when we explore the data, we need to look at that, explore the data and see what business would be interested in. Like they might be interested to know which vendor is performing well. Um, they might be interested in payment type, how customers are paying more. Um, you know, airport fee, what kind of airport fee? So we can look into it. Obviously, they would be interested in the pickup, like what's the most busy pickup time, but we can't do that on because it's too much. There is no cardinality in it. So we just decided. So I decided with PU location ID, but see, it's giving vary. So the top one is almost like 574, and the least one is 96. So the executors won't be running, like one will be running really fast and another one will be just like lagging. So as I said, it's trial and error. So I spent some time on it, and I said that, oh well, 8 is no good, 3 is no good. Let me try 4. So I'm just trying 4 without um, any columns or anything. It's just simple 4, because as we can see here, the 3, like out of 8. Um, 3 are not even good, so just kind of take a bit of a pinch of salt and just say, so it's worked. Now, technically, it's not working because I have 8 cores and this is just 4 partitions, so 4 executors running and 4 will be sitting idle. But oh well, what can we do? So that's what it is. Then this is just the code to once. So once you have the file downloaded, you just save it. Now it's recommend that you create a new folder and then save it, not overwrite the original like the primary data. Now this is the code, just to see whether partitions worked or not. And in this one, it's very tiny, but we can see the initial one, that where when the we let the default partition happen, Spark process like in 1.1380, and then when we did 4, it's did little bit better. So this time will be different for you, I guess, but it's working. It's at least working. So we're making bit good out of it, and this is just showing you that the code works. Now this is the Spark UI. This should be actually at the top, but I put it here because today, as I said, we're just keeping it very simple. We're not going to look into this at the moment. I'm still exploring it as well. I know how to, but I'm just going to come to that soon. So that's it. Hope this will be helpful, to understand practically after you have gone through all the amazing technical videos. Um, and please try and test other files with it and see what output you get, and let me know if it was helpful. Next, I'm going to talk about the shuffling, exactly the same logical way, not from the technical way. My aim is to talk logically, not technically. Um, so thank you so much. I really want to acknowledge all the YouTubers who publish great technical videos on this topic, which inspired me to come up with this one, because at least I couldn't find any practical end-to-end. The doing with the file, like how actually you start from where. So this is it, and catch you in the next video sharing. Thank you once again, and as I say, learn with dummy. See ya.